Good day everyone! Today I'm going to teach you about tautology and fallacies. Let's go!
Today, I'll be talking about tautology and fallacies. First, let us start with tautology. A tautology is a statement or proposition that is always true in every possible situation, regardless of the truth values of its parts. For example, if P and Q are true, then P is true. Also, the arrow symbol inside the parenthesis is read as AND. Then the arrow pointing to the right is read as THEN. When both P and Q are true, then P is obviously true. When either P or Q is false, the if-then statement is automatically true. In conclusion, the last column is true. In all rows, that means this is a tautology. Example 2. Every whole number is either even or odd. For example, 4, 7, 0, and 19. 4 is divisible by 2, so even part true. 7 is not divisible by 2, so odd part true. 0 is divisible by 2, so even part true. 19 is not divisible by 2, so odd part true. With all results are true, that means this is an example of tautology. Example 3. If P and Q are true, then P is true. I've got a situation here. Imagine you're analyzing a sports condition. You can only say someone is definitely playing basketball if both of the following are true. They play basketball, P, and they score points, Q. If you play basketball, then it is P. If you score points, then it is Q. Then logically, you're already playing basketball. If both conditions are true, P and Q, you play basketball and you score points, then you're certainly playing basketball. In the first row, P and Q are true, then you are playing basketball. In the second row, you do play basketball, P equals true. You don't score points, Q equals false. So the condition, you play and score, is false. In logic, if the condition is false, the full if-then statement is automatically considered true, no matter what comes after. So this row is also true. In the third row, you don't play basketball, P equals false. You do score points, Q equals true. The condition you play and score is false again. Since the condition didn't happen, we don't care what comes after. Logic says the whole statement is still true. This one is also true. In the fourth row, you don't play basketball, P equals false. You don't score points, Q equals false. The condition, you play and score, is also false. Again, since the condition didn't happen, the whole statement is true by default. This final row is true. So in conclusion, this statement is always true, no matter what values P and Q have. If the starting condition doesn't happen, the if-then logic stays true. And if the condition does happen, then P is obviously true anyway. That's why, if P and Q are true, then P is a tautology. It's always true in logic. Example 4. P or not P is a logical statement that means a proposition is either true or not true. It is always true because either a statement is true or its opposite. Must be true. There's no third option. In every possible case, one of them is guaranteed to be true, which makes the entire expression true. Let's say P equals it is raining. Then P or not P equals it is raining or it is not raining. First row, P is true. So P or not P is false. But since P or not P means P is true, the whole expression is true. Second row, P is false, so P is true. Even though P is false, the OR statement needs just one side to be true, and P is true. No matter what value P has, either P or not P will always be true, which makes it an example of tautology. Example 5. If P implies Q, it means if P is true, then Q must be true. Then, if Q implies P, it means if Q is true, then P must be true. Let P equals you study, Q equals you pass the test. If P implies Q is only false when P is true and Q is false, if Q implies P is only false when Q is true and P is false. But in every row, at least one of the implications is true, so the final expression is always true. Then this is a tautology. Now let's move on to the fallacies. Fallacies is a mistake in reasoning or logic that makes an argument invalid, even if it looks convincing at first. The first type of fallacy is a fallacy of affirming the consequent. It is a mistake in reasoning where we assume that if the outcome is true, then the original condition must also be true. It usually takes the form of if P, then Q. Q is true, then P must be true. This is wrong because the result can come from other causes. For example, if it is a dog, then it has 4 legs. This animal has 4 legs. Therefore, it must be a dog. This statement is wrong because having 4 legs doesn't prove the animal is a dog, since many other animals also have 4 legs. The fallacy of denying the antecedent is a mistake in reasoning where someone assumes that if the condition is not true, then the result is also not true. If P, then Q, P is not true, therefore Q is not true. The reasoning is invalid because even if the condition P is false, the result Q can still be true for other reasons. For example, if a number is 4, then it is even, but if it is not 4, we can't say it's not even 2. It's wrong because just because the number is not 4, it doesn't mean it's not even. Other numbers like 6, 8, or 10 are also even. Fallacy of circular reasoning. Circular reasoning is a fallacy where the conclusion is simply a restatement of the premise. It gives the appearance of proof, but does not provide any new or independent evidence. In short, it argues in a circle by assuming what it is trying to prove. For example, triangles have 3 sides because a triangle is defined as a shape with 3 sides. Therefore, a triangle has 3 sides. It's wrong because the argument doesn't prove anything new. It just repeats itself. Instead of giving real evidence, it assumes the conclusion is already true in the premise. That makes it circular, not a valid proof. False analogy. A false analogy is a fallacy where 2 things are compared as if they are alike, but the comparison is weak or inaccurate. It assumes that because 2 things share some similarities, they must be the same in other aspects too. This leads to a faulty conclusion since the analogy doesn't really hold. For example, students are like calculators. Since calculators never make mistakes, students should never make mistakes either. This is wrong because students and calculators are not truly comparable. Students can make mistakes. Calculators just follow program steps. Lastly, false generalization. False generalization is a fallacy where a conclusion is made about a whole group based on too few examples. It assumes that what is true for some cases must be true for all cases. This often leads to unfair or incorrect conclusions. For example, I met 2 students who don't like math, so all students must hate math. This is wrong because the conclusion is based on only 2 examples, which is not enough to represent all students. That is all. Thank you for listening.